are you saying that if we can estimate the phase noise, we can estimate the jitter
Absolutely.
thereof?
Yes,
So there
absolutely.
is a close correlation between
Yes,
the two?
absolutely. Yeah.
Okay, okay.
Yeah, we actually, on our analyzer, our phase noise analyzer, you can measure jitter. So it'll tell you this is the phase noise. You can look at the characteristic at different frequency offsets, but it'll also tell you what is the integrated jitter over some frequency range.
Right. So over a broad range of frequencies.
Right,
Yeah.
correct. Yeah.
So basically, that is the reason why we are interested in phase noise? Is that the only reason?
So there's lots of different applications. So if you look at kind of some of the key applications where phase noise is important, so like in radar, for example, right? In radar, I'm going to send out a signal, and I'm going to it's going to go out, reflect off something, come back, and then I'm going to compare my original signal to that signal in time.
True.
Right? So I'm going to measure the time, and I can get, characteristics about the shape and whatnot depending on the reflection.
Sure.
But if I have a lot of phase noise, right, it spreads out the signal. So when the return comes back, it's obviously a lot smaller, right? So I compare the original signal that has this width, and if this is really small, it's hidden by the phase noise of the signal. So it's actually desensitizing your radar, so you can't see the returns depending on some characteristics.
I see. So the phase noise is extremely important in applications like radar.
Like radar.
So you will like
Yep.
to reduce it to as much as we can.
Yes, exactly.